Hey everyone, welcome to The Explainer. I am absolutely thrilled to have you here today because we are diving into something genuinely fascinating. We're going to explore a new theoretical framework developed by engineer Mlhem, and it's called the Ozo-Mechanical Model. Now, we are going to look at some foundational ideas that attempt to radically reframe how we understand the very fabric of our universe. So get ready because we're about to look at physics through a completely different, deeply relational lens. To really set the stage here, let's just start with a massive fundamental question. Are mass, space, and time actually independent entities? For over a century now, physics has been wrestling with this classic disconnect. On one hand, we've got general relativity, which beautifully describes the macro universe using the smooth, bending geometry of space-time. But then, on the other hand, we have quantum mechanics, which governs the micro-universe using probabilities and these distinct quantized leaps. But what if they aren't actually separate domains? What if mass, space, and time are actually deeply entangled, acting together in a single, continuous system of balance? Okay, let's dive into this. Here's our roadmap for today. We'll cover the cosmic mystery, the Ozo-Mechanical foundation, triple relative equilibrium, entanglement mass, reinterpreting atoms, and finally, a standard physics showdown. Section 1. The cosmic mystery. The search for a unified physical framework. Moving right along to Section 2, the Ozo-Mechanical foundation, the core equation that literally flips the script. All right, here is the beating heart of the entire model. The core equation. Gm times m squared equals the reduced Planck constant times the speed of light. Let's break this down a bit. In traditional physics, we rely heavily on Newton's gravitational constant, big G. But here, the model introduces something new, Gm, the Ozo-Mechanical coupling constant. And this is absolutely crucial. Gm is not Newtonian gravity. Instead, it represents a comprehensive structural bonding strength. It's a massively huge number, roughly 1.5142 times 10 to the 29th power. And by using this new constant, the equation defines a natural reference mass, known as the Mlhem mass, or mm. Now, what's really interesting here is how swapping out that foundational constant completely changes our structural baseline. In standard physics, we use Planck units, right? And those depend on traditional gravity, G. Because G is so weak, the resulting Planck mass is relatively massive, and the Planck length is unimaginably minuscule. But Mlhem units depend on that new Ozo-Mechanical constant, Gm. Because Gm is so massively larger than G, the mathematical result totally flips. The natural Mlhem mass becomes incredibly small, and the natural Mlhem length becomes vastly larger. It's just a completely different scale for the foundation of physics. Section 3. Triple relative equilibrium. The cosmic mobile of mass, space, and time. The fundamental relation here is wild. It tells us that the ratio of masses, multiplied by the squared ratio of their orbital times, multiplied by the cubed ratio of their spatial dimensions, must always equal exactly 1. I want you to think of this like a giant, delicate cosmic mobile hanging from the ceiling. If you change a mass on one side, or if you alter the orbital time, or shift the spatial dimension, you simply can't do it in isolation. The other components inherently and automatically force themselves to shift around just to maintain perfect stability. Everything is structurally obligated to balance out. And this matters because it means nothing in the universe happens in isolation. Everything is intimately tethered to everything else. Section 4. Entanglement mass. Rethinking spatial extension and particle bonding. So the model introduces a brand new metric called Ozo-Mechanical entanglement mass, represented by μ. The formula is beautifully simple. It's just the actual mass divided by the coupling constant. What this does is act as an effective measure of a system's internal bonding capacity. And honestly, here is the truly paradigm-shifting part. In this framework, energy isn't some independent, magical property just floating around. Through the equation energy equals μ times c squared, energy is defined as a direct reflection of structural entanglement. Basically, energy is the geometry of the bond. And this creates a beautifully counterintuitive reality. Let's take the proton versus the electron. The proton is heavy, right? Well, in this model, that maximum mass yields a minimum spatial extension. It's a highly compressed entanglement, forming the lower limit of entanglement capacity. But look at the electron. It's incredibly light, and that minimum mass yields a maximum spatial extension. It forms a highly extended structural geometry, representing the upper limit of entanglement capacity. Simply put, because of how they structurally entangle to maintain that balance we talked about, lighter particles actually take up a much wider spatial footprint. Section 5, Reinterpreting Atomic Structures. How quantization emerges from stability. And this brilliantly illustrates the point. In standard physics, the fine structure constant, which dictates how light and matter interact, is essentially an experimental given. We just measure it and accept it. But in the Ozo-Mechanical Model, if you calculate the fundamental coupling constant for a proton and an electron together, it naturally derives a number incredibly close to 7.297 times 10 to the negative 3. It literally produces the fine structure constant naturally, which is honestly kind of mind-blowing, just by looking at the structural saturation between the mass and quantum action. We actually see this natural emergence again when we look at orbits. In traditional physics, the Bohr model essentially dictated that quantization is just a rule. Electrons just must sit at specific levels. But let's narrate the progression in this new model. First, velocity arises completely naturally from the actual mass coupling strength. Then, the orbital radius dynamically adjusts to balance that exact velocity. And finally, stability is only reached when the angular momentum perfectly balances out to the reduced Planck constant. So you see, quantization isn't some forced external rule. It is simply an emergent byproduct of the system desperately trying to stay physically balanced. Section 6, Standard Physics Showdown. Let's compare the Ozo-mechanical lens with our established theories. So the crucial point is really how these core philosophies stack up against each other. In standard physics, quantization is imposed. We consider it fundamental. But in the Ozo-Mechanical Model, it's emergent from structural stability. Standard physics views gravity as space-time curvature, while this model views it as a coupling density gradient. Standard physics sees the speed of light as a strict kinematic limit, but this model sees it as a structural saturation limit. And while standard physics views Planck's constant as the fundamental unit of quantum action, the Ozo-Mechanical Model interprets it as the ultimate scale of natural stability. Let's actually expand on those last two concepts because they are huge. This model mathematically reframes general and special relativity. Gravity is no longer a bowling ball bending a trampoline of spacetime. Instead, it is a gradient, a literal shift in the density of how mass couples together. And the speed of light? Well, it's not just a universal speed limit. It's a saturation limit. It's the point where the coupling constant approaches 1. The core premise here fundamentally rewrites our intuition. Literally everything we observe is simply a result of variations in coupling density. Which brings us right to the grand thesis of Mlhem Ashul's foundational paper. And I quote, "Physics here is not a set of isolated equations, but a single continuous cycle of interdependence. It entirely removes the walls between the micro and the macro, proposing that the universe is just one unified, breathing system of relational geometry." It completely shifts how we look at reality, doesn't it? And I want to leave you with this final, provocative thought to ponder today. If quantization, literally the very foundation of quantum mechanics, is actually just an emergent property of structural stability, what else in our universe is just an illusion of balance? Think about that for a while. Thank you so much for joining me on this deep dive. Keep questioning, keep learning, and I'll catch you on the next explainer.